Hello, today we're going to look at radioactive contamination, but first we're going to look at ways in which we can detect radioactivity. The first is by measuring something called the activity, and the activity is the rate at which a source of unstable nuclei decays. So if we have a material, for example, a little diagram of a material there, if we have a material that's decaying, or it has unstable nuclei that are decaying by giving out radiation, the speed at which that happens is called the activity. And there is a special unit we use for this activity, and it's called the becquerel. Becquerel, and the abbreviation is a capital B with a small q. We can also measure radioactivity using what's called the count rate, and that's slightly different in that this is all about measuring the count or the number of decays per second. It's the number of decays per second. Sometimes you might be given that in number of decays per minute, but this is measured using a detector. This is measured using some sort of detector, and the most common one you might come across is one that's called a Geiger tube or a Geiger-Müller tube. And there it is there on the left-hand part of that diagram. So there's our Geiger-Müller tube, and if we had our radioactive material that was giving out nuclear radiation, it would give it off in all directions depending on how it's arranged or contained, but the number of decays per second as measured by the Geiger-Müller tube there would be called its count rate. And there's a meter on the end of the tube that will give you the count rate per second. Okay, so two ways of measuring or detecting radioactivity, the activity and the count rate. What we're going to look at next is the idea of radioactive contamination, but we're going to compare it to something called irradiation. So we have radioactive contamination there on the left and irradiation on the right, and what we need to be able to do is to describe what each one of these are and make a comparison of the two. So we'll start off with the idea of contamination, and this is basically when we have the unwanted presence of radioactive materials on other materials, the unwanted presence of radioactive materials on other materials. And the reason we have a problem with that is because the contaminating nuclei, in other words, the material that's doing the contaminating, the nuclei of those atoms, they decay on the material and they give out possibly alpha, beta, or gamma radiation, and that can be a hazard. We know that alpha is the most dangerous, most ionizing, beta is less so, and gamma is less so. Alpha is the most dangerous in the body, but either way, these are hazardous if we have, or it is hazardous if we have contamination. One example is the Fukushima nuclear reactor disaster in Japan in 2011, and as a result of this disaster, we had the release of two particular materials, two radioactive isotopes. One was iodine-131, and the other one was something called cesium-137. Now, both of these were quite dangerous in terms of the fact that they contaminated surrounding areas. Cesium has quite a long half-life of about 30 years, and iodine a much shorter half-life, but nevertheless both still quite dangerous due to this idea of contamination and leaving materials in the environment contaminated and radioactive. Okay, so half-life of about 8 days for iodine. Now we can compare that to the idea of irradiation, and irradiation is when we expose an object to nuclear radiation. So it's the exposing of an object to nuclear radiation. Now the key and important thing about irradiation is that once the source of radiation is taken away, it's gone. The radiation is gone and the object does not become radioactive. It does not leave the object radioactive after the radiation is gone, which is different to contamination. Irradiation can be useful. It's used to sterilize food. Fruits are often sterilized using irradiation, but it's also used to sterilize medical equipment, the kind of equipment that might be used to carry out surgery. But those uses are very carefully controlled. The radiation is used in very carefully controlled doses. Irradiation can still be a hazard because we might be exposing objects to alpha, beta, or gamma radiation, which could damage living tissue. But as we said, very carefully controlled when used in sterilizing food or medical equipment. Okay, so this is the details behind how we measure radioactivity or how we detect it, plus the differences between radioactive contamination and irradiation.